So it says that you have a restaurant in which there is a single chef, and you are given an array of customers where a customer will arrive at this arrival time and his dish needs this much amount of time to prepare. Now they are saying the condition is when a customer arrives, he gives the chef his order and the chef start preparing for it once the chef is idle. So I can have multiple customers coming in, but it might happen that okay, the chef is busy preparing an order of a previous customer. So chef can only start preparing an order of a current customer when he gets free. Now the customer waits up till the chef finishes preparing his order. The chef does not prepare food for more than one customer at a time, which means chef will prepare one food at a time. He is, you know, single threaded. The chef prepares food for customers in the order they were given in the input. So chef, the first customer, his food will be prepared first, then next, which means all the customers will be coming in the order of their arrival time is actually in the increasing order. Their arrival time will always be in the increasing order. As you can see, it is non-decreasing, or you can say increasing, both are same, not technically but for feel. Now we have to find the average waiting time for all the customers. What is the waiting time? Waiting, again they are saying to find the average in one, like two, the solution should be within minus 1 from the actual answer, and it should be considered. So what is the average waiting time? Waiting time for anyone is that if the customer ideal in the ideal scenario, a customer has come, in the ideal scenario he should be delivered food right now. That's the ideal scenario. So technically the customer who came at 1, he was expecting the food at 1, but because the food will take this much amount of time to be prepared, and god knows what if the chef started preparing the food at the time 5, and it will take two amount of times. So actually the customer got the food at 5 plus 2, which is 7. He got it at the 7th second or 7th minute or 7th hour, which gives the waiting time as 6. So this is how we find the waiting time. Waiting time is nothing but ideal time when the customer should be ideally have gotten the food, which is 1, because as soon as the customer comes, he should have gotten the food. Now, the actual time, which means the actual time when the chef started preparing, which is 5, and for sure, 2 amount of time will be for sure taken. Thus, the time will be my 7. The difference will be the waiting time, which is 6 for the customer. Now, how will we find it? So, one thing is obviously that I will have to maintain one thing, that my chef, is he free or not? And if he is not free, then up till what point he is busy? I'll maintain my busy up till, that my chef is busy up till what point. Then I have just plotted this. Okay, the first customer came at time 1, his food will take 2 amount of times. The second customer came at time 2, his food will take 5 minutes of time. The third customer came at time 4, his food will take 3 amount of time. And for every customer, I will have to find its corresponding waiting time. And I will have to take the sum of the waiting time and will divide by the number of customers, which is 3 in this case. That will be my average. So the prime aim is finding this waiting time. This is my prime aim. If this is my prime aim, then how I can find it? The same way what we learned, that what a waiting time is. We realized the waiting time is nothing but the task end time, when the task or when the food is actually made and in your hand, minus the task ideal start time, in which in this scenario task is food. So food ideal start time will be the arrival time of the customer. So I can say that the food to the customer should be delivered as soon as the customer came in. Customer came in at the time arrival time. So this will be the arrival time. Task ideal time should be the arrival time. But task end time will depend upon when the customer came in. So it is the, sorry, when the chef got free. So it is the actual start time of the food making and the time taken by the actual food to be made, right? Now, the actual start, this, this is already given, this is equal to time. This is already given the problem that how much time the food will take to get prepared. But the actual start time, it again depends upon two things. That the chef can be free at that moment or the chef is not free at the moment. If the chef is free at the moment, then the food will be prepared. I will start preparing the food after the customer has come in, right? It is not possible that, okay, in the very beginning at time zero, the chef was free, but he cannot start preparing the food until and unless the customer comes in. Customer comes at time one, so he will start preparing the food at time one. So if the chef is free, he will start preparing the food when the customer will come in. If the chef is busy, the chef is busy, he will start preparing the food. He will start preparing the food when he will get free, right? So if the chef is busy, let's say up till point two, so he will start preparing the food at point two onwards. Cool. And again, make sure that this also should be valid. Let's say if the chef is busy, if the chef is busy, let's say if we take this scenario, if the chef is busy up till point 15, or let's say up till point 16, but the customer is coming in at 20, so obviously I will start preparing at a time 20 because that's when the customer came in. So this makes us feel that because of this logic, it makes us realize that our actual waiting time is nothing but maximum of arrival time or my chef busy up till time. For sure, I will have to add the time which the food will take to be made, and I will subtract the actual arrival time of the customer. Then I will get its actual waiting time. Okay, I have got the waiting time, but there was one thing. Okay, I have to find the waiting time for all the customers. So I have got it and I will get it with this formula. But as I will basically handle every customer, I will also have to make sure that the chef will get busy for that moment. So this is as you know that this was the task end time and task is delivered by the chef. So chef will be busy up till this point. So I can easily say that this thing is that chef will be busy up till this point. So I have to update my busy up till by maximum of arrival time, comma busy up till plus time. This is up till this point my chef will be busy delivering that specific customer. Cool. This is the only thing which are true. Let's simply do a simple trial and we'll quickly wrap it up. So in the very beginning, my chef was not busy. Busy up till is 0. My customer, again, firstly, how much the first customer will be waiting. So firstly, customer came at 1. The chef was free. So chef, ideally chef could have started at 0. Then the food time will be taken as 2 and the actual arrival time was 1. So the waiting time in the very beginning is 2. Okay, and the waiting time in the very beginning is 2. Now my chef was busy up till what point? My chef was busy up till this point, which is 3. My chef was busy up till 3. Next time the waiting time will be, I will simply say that the arrival of the customer was at 2. My chef was busy up till 3. So technically the food preparing will start at point 3. Then food preparing will take a time of 5. But I'll also make sure that the customer arrived at time 2. So this will say that 3 plus 8, like 3 plus 5, which is 8, minus 2, which is 6. Okay. 6 is the waiting time. I've got this waiting time, I've got this. Again, my prime aim, Maksat, was to find the waiting time only and take the sum and then take the average. Next time, my chef will be busy up to what point? My chef will be busy up till 8. Up till 8, as you can see. So my chef will be busy up till 8. Then again, what is the waiting time? Again, the customer came at 8. The chef was busy up till 8. This customer came at 4. The chef was busy up till 8. And then I will take some time to make food. And then the customer was waiting since 4. So actually it is 8 plus 3, 8 plus 3, 11 minus 4. Simply answer is 7. So my actual time is 7. Thus, you can simply see that 6 plus 2, 8 plus 7 is 15. 15 is the actual, waiting time summation. divided by the average, which is the number of customers, and thus the answer is 5. Now, as you can see, the average waiting time is 5. Now, just to give a quick recap, what can happen if I have some gaps? Because in the very beginning, my chef is busy up till point 0. So technically, the first customer, it came at point 5, but my chef was free in the very beginning itself, but he can start preparing only at point 5. So this is telling the actual time when the chef can start preparing, he will take 2 time, and the customer is waiting since 5. So he's actually taking 2 time. So 2 is the waiting time for him. And ultimately the chef will get free at 7. The chef will get free at 7. He was busy up till 7. If he got free up till at 7, I can simply say that the customer came at 5, chef came at 7. He will take the time of 4 to prepare, and the customer is waiting since 4. So it is nothing but minus 1 and 7. 7 minus 1 is 6. So my wait time here is 6. Again, my chef is busy up till 7 plus 4, which is 11. Now again, waiting time is maximum of waiting time, which is 11. Obviously, I can say firstly 10 customer waiting time, then customer coming arrival time. Chef got free at 11. He will take 3 time to deliver the food, and also the customer technically came at time 10. So thus the actual waiting time will become 11 plus 3, 14 minus 4, sorry, minus 10, which is 4. Again, at this point, next time the busy up till will become 11 plus 3, which is 14. But here the customer came at 20 only. So my chef should start preparing at 20 only. So I will say maximum of 20 comma 14 plus 1 minus 20, which is 21 minus 20, which is 1. Thus the waiting time will only be 1, which is this food only. And this simply take the summation and take the average of it. You will get your answer. That's the code. This 2 lines only. And again, this we simply derived by what the actual waiting time is. And then this line. Cool, let's say the code is exactly same. It simply says that we have busy up till, again, we took long, again, you can just take long also, because of arrival time and our time, it is 1e4 plus 1e4, it can go up till 1e5. Like this can go 1e5 times. So this can be a large number, because I can have as many gaps as possible in this. So yeah, I can simply say that start with first customer, because I know the customers are coming in the order itself. I will check their arrival time and their time of the food, which will take for that specific customer. I will compute its waiting time, which will be maximum of arrival time busy up till plus time minus arrival time of the customer. And I will update my busy up till for that specific food, that the chef will be busy preparing that food up till this point. And then I will repeat that for all the customers, keep on adding my waiting time, and ultimately it will be average, which is waiting time upon n, just to make it converting to double. And that's all. This is a simple simulation problem taking a time of O of n and space of O of n. Cool. Thank you for watching. Bye bye. Take care and see you. We join Discord. Bye.